is our NXT robot that we have made for the past 9 weeks, and now we must record a video to show you what we've done. And this is our video. Our first part of the video is the construction of the robot. Pretty much took that couple stuff, Brady. Look at this. Took this part and a bunch of wheels. There to this next contraption. Not much to it. They got a booklet in the computer. It shows you how to do it all. It's pretty cool. And you can add different stuff, like we had traps on here. And that would be the first phase of our video, the construction phase.
How long did it take?
How long did it take? It took us about 3 days.
3 days to build an entire robot. That's pretty good.
Not really.
What is some of the other stuff that you've added on
Christmas lights. Actually, there's a stoplight. We have our light sensor on here. And we can put bigger gears on here, which we will show you later. And that's about it.
These are NXT robots, and I'm talking about the software right now on the computer and how we made it do all the turns and how it goes forward. And how it runs these motors is there's a motor block on the computer, and you have to tell it how many degrees it has to turn, which makes like that, forward or backwards, and then you can make one motor turn and one motor stay in position and make it turn. And there's a wing form lock on the computer that'll, after both wheels have gone forward or done their entire route and then stopped, it'll, after you have that, so you have a wait block. And then the wait for block makes it to wait for the next program. This is our point turn on our NXT, and what it's going to do is one motor is going to be turning forwards, and the other one's going to be turning backwards, and this part of the robot's going to stay in one spot. It's just going to revolve around that. So this is our point turn. Wheel got stuck. So as you can see, as you watch this time, this part of the robot right here is going to stay in one spot. That's why it's called a point turn. Hi, this is Brady Noah with the NXT robot, and right now we're going to be showing you how we're going to make our robot go 80 centimeters. So the diameter of this wheel right here is 5.5. So to find the circumference, we have to take the diameter times pi, which is 3.14. 5.5 times 3.14 is 17 centimeters. So to make the robot go about 80 centimeters, you want to say, we have to take 80 divided by 17, and we get 4.7. And then, since this is measured in degrees, a full turn is 360 degrees, so we have to take it times 360. And you get 1,694 degrees, so that's how many wheel rotation, or degrees, that the wheel has to turn, go around, or close to 80 centimeters. So, this is Brady and Noah with the NXT robot.
Hello, this is our light sensor attachment, in which our light sensor here will detect the black and the white of the floor. By doing that, it takes the average of the dark and the white, and which makes it a threshold, which will follow the line. I'll show you. You can see when it sees the dark, it goes right, and when it sees the lighter, it goes left, making it go forwards. And that's our light sensor attachment.